Hi everybody, my name is Nicole and I am going to be doing some more non-standard methods and models for addition, subtraction, multiplication, and division. And for the video today, we're going to be using proper fractions and mixed numbers. So first, let's go ahead and start with our addition. And for this, we are going to talk about the area model for proper fractions. So first thing we need is our problem, of course, and that's 2 over 4 plus 2 over 6. So normally we would solve this by taking and making the 4 and the 6 the same number. And we do that by finding the least common multiple of these two numbers. So we know that 12 can easily be done by multiplying another number to both of these numbers. So what we would do is find out what times 4 would give us 12, and that would be 3. And whatever we do to the denominator, we also have to do to the numerator. So we would have to do 2 times 3. And then when we look over here, we know that 6 times 2 equals 12, and again, we have to do the 2 times 2 to the top. Okay, so then we would get 2 times 3 is 6 over 12, 4 times 3, plus 2 times 2 is 4 over 12, excuse me. So then all we would have to do is do the 6 plus 4, which would give us 10 over 12. Then we would just simply simplify. And we know that 2 goes into both of these numbers. So we would divide both the top and the bottom by 2, which would bring us to 5 over 6. And that is the answer for this problem. However, we are going to try to solve it through the area model now because it is a more visual way to find out how to solve this. So again, our problem is 2/4 plus 2/6. And to do this, we do not have to simplify or change the denominators. All we have to do is draw our diagram. And we're going to look over here and we're going to see that the denominator of the first number is 4. So that tells us we need 4 columns in this diagram. So 1, 2, 3, 4. Okay, and then now we know that we have 2/4. So we're going to take and we're going to color the 2 columns that we have. Next, we can look over at our second fraction, and we can see that the denominator is 6, which tells us we need 6 rows. So 1, 2, 3, 4, 5, 6. Okay? And instead of going ahead and coloring in over top of these 4 boxes, we want to make sure that we're adding extra boxes. So what we need to look at and see is that we know we have 2/6. So we know we have 2 rows out of the 6 rows. So we count the number of boxes in the 2 rows. So there's 1, 2, 3, 4, 5, 6, 7, 8. So we need to color in 8 more boxes. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that tells us that our answer is going to be the shaded blocks over the entire diagram. So this tells us that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 shaded blocks over the entire diagram, which is 21, 22, 23, 24. So our answer then would be 20 over 24. However, we are not done because we can in fact simplify that. Right off the top of my head, 4 comes into mind because 4 will go into both 20 and 24. So let's just divide both because we have to do the same to both the numerator and the denominator. And 20 divided by 4 is 5 over 24 divided by 4, which is 6. So by using the area model, we get the same answer as when we do it by solving using a common denominator. This is just a more visual way to see the problem worked out. Okay, so that's our addition model. Next, we're going to move on to our subtraction model. And we are going to be changing mixed fractions to improper fractions, or mixed numbers into improper fractions. Okay, so first we need a problem. And this time our problem is going to be 7 6/9 minus 3 2/5. So this can be solved multiple ways. Some people might go ahead and switch it to an improper fraction before solving it. But for this problem, I'm going to take and I'm going to leave the numbers as is and solve it by separating the whole numbers and the fractions. So 7 plus 6 over 9 minus 3, and then we have to take this minus sign to both numbers. So it would be minus 2/5. So then what I would do is I would take and I would calculate the whole numbers first and get 7 minus 4 equals, 7 minus 3 equals 4. Let me write that again. 7 minus 3 equals 4. And then we would have 6 over 9 minus 2/5. Now, as we did in the previous problem, we did have to change the bottom so that they're the same denominator. So we're going to do that. So we're going to do 9 times 5. And of course, we have to do 6 times the 5. And we're going to do 5 times 9 and 2 times 9. Because by doing 9 times 5 and 5 times 9, we get the same denominator. So 6 times 5 is 30 over 45, because 9 times 5 is 45. And then we need to subtract 2 times 9, which is 18 over 45. So then our answer would be 12 over 45. Okay, so then we know that this is not complete because you can still take and divide a number by a number. You can take and divide one number by both the numerator and the denominator so that we can simplify this problem. So if we do 12 divided by 3 and 45 divided by 3, we will get 4 over 15. Okay, so our answer for this equation is 415. And of course, we have to remember that we had a whole number and it was 4. So then we need to add those two together. And we would get 4 and 4/15. So our final answer is 4 and 4/15. Now, we are doing mixed fractions changed to improper fractions. So again, this is a mixed number. So we need to make it an improper fraction. And to do so, we take and we do 15 times 4, which is 60, plus 4, which is 64, over the 15. Okay? And then we have our improper fraction. In some questions, we'll ask you to simplify to an improper fraction, and others will have you just leave it as a mixed number. So either one is correct. It just depends on the question that's being asked. Okay, so let's move on to our multiplication. And for multiplication, we're just going to do our standard method of multiplying fractions. For this problem, we are actually going to do 2 problems. And again, we are going to be basing it on the standard method. Okay, so 3 over 4 times 2 over 3. And for this, we do not have to change the denominator or make them common multiples or anything like that. All we do is multiply the numerator times the denominator. So 3 times 2 is 6. 4 times 3 is 12. So then we would need to simplify, and we know that 6 goes into both the numerator and the denominator. And this would give us 1 over 2. Again, I will do another one because that was easy. 1 over 7 times 2 over 3. 2 times 1 is 2. 7 times 3 is 21. And again, you cannot simplify that. So we are done. So the answer is 2 over 21. And that is just the standard method of multiplication. Okay, now we're going to do our division. And for the division, we're going to do something similar like we did for the addition. I'll just do divided methods. And we are going to be looking at colored regions, which sometimes can be labeled as the area model, as we did earlier. Okay, so our problem is going to be 5 over 6 divided by 1 over 2. So again, we know that we need to draw a diagram. And of course, it's not perfect, but that's okay. And we are going to make 6 columns because we know the 6th is the denominator. So that's our columns: 2, 3, 4, 5, 6, and we're going to cut that in half because there is 2 in this denominator. Okay, so going back to the first, it's 5/6. So that tells us we have to color in 5 columns. 3, 4, 5, and 1 needs to be circled. So this tells us that our answer, we're going to take and count all the shaded first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our numerator. And we're going to put that over however many blocks that we circled from this fraction. 1, 2, 3, 4, 5, 6. 10/6, we know that we can divide both of these by 2, which would give us 5/3. And again, this is an improper fraction, so we can make it a mixed number, which would then be 1 2/3. All right, that's all I have this time.